Welcome to Common Computer Private Limited, e-learning program of network interconnecting devices. So today we are going to discuss about the interconnectivity devices for establishing the network. So connection of multiple computers, we call it as a network. But for connecting those computers locally or over the globe or remote areas, we need the cables and connectors. Along with that, we also need the connectivity devices. So in this session, we are going to discuss about the different types of connectivity devices available in the industry. Over the past, what kind of devices we used, and now with the current technology trending, so what is the devices we are employing with the different type of offices based on their budget, based on their environment, based on their design. So we'll discuss all those things in this session. So an interconnecting device is any device that can enable computers to exchange data on a network. So it means that it can be a hub or switch, any kind of physical device which is used for connecting two computers. So it can be a small LAN network or an enterprise wide area network. Definitely we need a connectivity devices. So LAN we use switch or hub. Case of WAN we use router, but it is a interconnecting device. So it is going to be the backbone of a network because it's a network infrastructure, we call it as backbone of a network. So without which we will not be to establish the communication with the remote offices. Our office will get isolated if the link is down, if the device is down, and we will not be able to do a kind of transactions with the other offices. So that is the importance of having network interconnectivity devices. So normally we had hub, repeaters, bridges, switches, routers, and gateways. These are all the common devices we use as interconnectivity devices. And some of them are very old, which is not used in the industry, but most of the devices we are currently using in the industry. Let's start with hub. Hub is a small device where it is helping us for connecting a limited number of ports. Maybe we started with 4 ports and then later 8, 16, 24 ports, not more than that. We go for connecting hubs. So normally 10 to 15 systems we recommended with the help of hub. Sometimes we used to cascade the hub one hub with another hub. If at all I have more number of systems, suppose I have 20 systems or 30 systems, I have 8 port hub. So what I can do is I have to use a uplink cable to connect multiple hubs together so that I can connect all the 30 systems in a single office. So here we recommend to have 10 to 15 systems as a single network. If you expand more than that, what happens is because these are all not intelligent devices like your switches or routers, so they will not be able to pass on the informations quickly. And this is running with 10 Mbps or 100 Mbps, not more than that. So uh, obviously will not have good communication between the system, or possibility of sending and receiving the data will be very less. So that's the reason we stopped for a limited number of systems. With 5 or 10 systems, it is good for a kind of lab setup, internet browsing center, or university college labs, computer lab or department lab. So those places we can use this kind of hubs where you'll get 100 Mbps speed and a good communication between the devices. So it doesn't have any intelligent device, so it passes on the information from one system to other system. We have CSMA by CD, CSMA by CA, carrier sense multiple access with collision reduction. CSMA by CA, carrier sense multiple access with collision avoidance. These devices falls under CSMA by CD because it detects only the collision, but it cannot do anything with the avoidance and all. So obviously, it falls under low communicating device compared to other device. This operates on a physical layer, and this doesn't have any kind of additional features like filtering the data or filtering the package from source or destination. Those kind of segregations it cannot do. It can just do a catch and dispatch kind of job. So hubs, we connected different systems in hub. We call it as a star topology normally, and hub and spoke also. We can also call it as a hub and spoke method, because in cycle we have hub and spoke, right? So in the same way, the connectivity device will be in the middle, or in the sense it will be in the center of the office. All the connections from the systems will be reaching to the hub, so that we get equal number of length with all the systems. Otherwise, few systems will have a less size length of cable, and a few systems will have more length, because of which it may lose the existing communication. So though it is called as hub and spoke, if at all I have multiple hubs available department wise, I have to connect. So I may go for a hierarchical level of connection, right? Connecting two hubs, I'll use another hub for um, connecting both the hubs. So this is the hierarchical way of connecting hub star topology. So we had active hub and passive hub. In the hub itself, we have two classifications. So in case of active hub, it is able to amplify and regenerate the information signal. So whatever it is receiving as an input, it will be able to amplify to the destination port. This has advantage of amplifying the incoming signal, so it can forward to the multiple devices. Normally in hub, so there is no advanced mechanisms like switch, so it sends the information to all the ports, all the systems. Then the respective system will acknowledge, the rest of the systems will deny. So that is how hub will be communicating. That's the reason we get more collision domains in the hub. So if at all you have 8 systems, 8 ports, you will have 8 collision domains. In case of switch, you will have only one collision domain. So that is the advantage of having switch. So this hub is also known as a multi-port repeater, because it is amplifying the signal in a better way. So it is also called as a multi-port repeater. Passive hub less than the capability of active hub, so it is just a dumb terminal for connecting multiple systems. You cannot even expect quality nature of active hubs in the passive hubs. So there may be difference in the rates in the olden time, based on the requirement they have purchased this kind of hubs. Advantages: less expensive compared to the next level devices. So covering the distance maximum 100 meters, not more than that. And in the hub side, no processing is done, it is doing only catch and dispatch, so it will be faster. Disadvantages: it doesn't have any intelligence to filter the traffic, no switching table, no MAC address filtering, all those things. It will broadcast to all the ports, which leads to inefficiencies and wastage. So that's the reason we call it as a collision domain. So it sends the data to all the systems wherever it is not required also. If suppose 8 port hub is available, and one system is triggering the data to other system in the among the 8 systems, so this one system will send the data to all the other 7 systems, leaving the source machine. So all the 7 systems will get the data. Whoever is wanted to get the data, they will consume it, and they will retransmit the acknowledgement. So that is how the hub transmission is happening. And we call in individual port, we have a collisions, right? Between the data, there will be collisions occurring, and that's the reason we had slow transmission of data in case of hubs. So repeater, so advanced form of hub is a repeater. So it is used in case of long distances, like you have a campus area network or a factory network where you wanted to extend a few kilometers and all, right? So in that case, we'll have to go for having a repeater. So we'll be giving the input, the repeater will amplify the signal, and it will retransmit the same data in a good manner. Normally in case of cable TV communications, you would have seen they will install the repeater after 4 or 5 streets, so that any signal is reaching after a lot of transmission losses. From that street, that home, the booster will be there, it will boost the signal, and next set of people will get good communication of the cable TV with good clarity in the pictures, right? So in the same way, repeater is also established wherever there is a requirement after certain distance. So it will just receive the data, amplify the data. If there is any low volume of signals, it will amplify with the higher signal, and it will help you to retransmit the data in a good manner. So that is the purpose of having a repeater. So receiving the data, it works in all the layers. Functions of a repeater. Repeater receives signals from our network segment and retransmit to the next network segment. Here it shows like it gets the data in a bad shape, whereas after filtering the data with the help of repeater, it is going in a good format. So repeater forwards every frame. It has no filtering capability. It doesn't have any intelligence to filter the frames. So it is working in the data link layer and operates with the help of frames. So it can extend only the physical length of the network, not a logical connection, but it can be used for extending your physical connection. Like in a factory, you are establishing another network. So you can put one repeater, and then beyond that, you can have one hub or switch. Then you connect the systems to the hub. Advantage, it is helping to extend the length of the network, strengthening the weak signal and removing the unwanted noise. So data transmission may happen faster. It has no filtering capability. It cannot connect to different architecture. So it can support only Ethernet or any other specific architecture, not as a combined one. Number of repeaters used should be less. Since it is amplifying, we cannot go for adding hundreds of repeaters. There should be some 5 or 6, less than 10. Otherwise, no, the purpose of having repeater will be wasted. Next one is a bridge. So bridge is normally a device which is used for connecting to a separate network, that is Ethernet network only. Both of them are Internet. I mean Ethernet. So it will be helping to connect both the Ethernet network. So bridging occurs at the data link layer. It works in the layer 2 of OSL layer, and it is helping to read the data in a better way compared to other devices. The hardware address is also read from the data, which is called as a MAC address, media access control. It will be capturing all the details about the packet which is receiving. Function of a bridge: when the frame enters, it not only regenerates the signal it receives. So bridge will be regenerating the signal. Whatever data it gets, it will be regenerating, so that if there is any weaker part, so it will get rectified. And it is also checking the source and destination address of the frame. So from which system it is generating the data and where it has to uh, delivered. So both source and destination information is available, and it maintains a table with the details. It will be marking in the table itself, and it is sending the data to the concerned system, right? So not like hub. So one transmission it's get transmitted to multiple system, but in case of a bridge, it will have destination address. So directly the communication happens between the endpoints from here to that another endpoints. So if suppose the destination's address is in the same segment, so we'll have multiple networks, right? So wherever I want to transfer the data, that system falls under the same network. So it will be identifying the data from the table and shares the information to the particular system. If not, it will go for forwarding the frame to the next segment and find out whether the matching destination is available in that place or not. So this is how bridge operates. So it helps to connect multiple networks together. Advantage. So bridge, it's a form of device which is released before the switch is getting released. So you can see the features which is similar to the switch which is available now. So it minimizes the unwanted traffic and it acts as a filter. So there will be when only specific traffic is going from the particular system to the other system. It will not be sending the junk data, and it minimizes the network congestion. Error links can be easily identified with the help of the checksum details, and It helps to lower the data load over the data link layer. So all these things adding the advantage with the device, and it is giving the benefit to the end user. Disadvantage: the speed is slower than the repeater, but it is faster than the routers because it is doing very specific process of sending the data from source to destination. So this can be done faster compared to other service providers. So cost is expensive than repeaters, but a bit cheaper than routers. So since it is having advanced technology compared to repeater, it is costlier, but compared to router, it is cheaper. This cannot handle multiple parts. It will handle only very limited parts. So this is the advantage and disadvantages of bridge. Switch. So it's an advanced form of device which is used for connecting multiple systems in a network. Um, so it depends, like 16 port, 48 port, what 24 port, whatever the size you are buying. So this can communicate with that particular switch in the network. So it is used for connecting multiple segments also, provided you have routing protocol enabled in the system. And suppose person in the HR department, person in the accounts department, person in the quality department, they wanted to interact, so they'll be able to provide a secure channel for establishing the kind of network connection. So all these things can be possible with the help of L3 switch, manageable switch. Okay, so non-manageable switch, we cannot do anything. We can just use it as a connectivity device, so not more than that. So it performs data link layer function, that it looks at each packets or data and determines from a physical address. So this is also called as a, it works on two different layers. So there are some switches which is called as a L3 switch. So it means that it will act as a L2 switch and L3 switch also. So separately, so it will be useful for communicating to the network. And L3 switch will have some advantage, like we'll be able to manage some of the parameters in the switch, but L2 switch you'll not be able to handle anything. So whatever the default connections, we'll have to go with the default connections. So connecting switches with the systems, this is how you connect your systems with the switches. So a switch allows more than one system to get connected, and it is faster than the previous devices, and it is also maintains a table, MAC table, where the source MAC address, destination MAC address will also be captured during the communication. So switches having a separate learning process, like when the switch is getting turned on, so what happens is the switching table will be very free, empty, and it checks all the ports available in the switch and finds out some of the ports are connected with system and some of the ports are left empty. So it will be marking all the details, and it starts building the switching table. So in the switch, so that it learns like from which port the system is getting this kind of information, and based on which they'll be marking the device and use it for a specific purpose, transmission purpose. So this becomes very easier for sending and receiving the data within the switch between the network. So I can use with a very effective manner, and I'll have faster communication with the help of this technology. Advantages: only for forward frame as needed, so it cannot forward it to many people. Only when requirement comes, it will be able to communicate. It extends the geographical span of the network, so it is helping you for expanding the network. And the separate segments allow longer distances, improves privacy by limiting scope of the frames. So these are the advantages. Disadvantages: switches are not good as routers, because always the higher device is the highest device in the organization. So So compared to router, the switches are not that much available. So we'll if I go to the next level, the router will be the best one, and beyond that we have other devices that will be better than the router. Okay. So here, for just for reference purpose, we are saying it is not good as a router, but real time we can take L3 switch, which will also function as a router. So it is difficult to reconfigure if any network error occurs in multicasting. So we will not go for multicast connection. Mostly it will be from uh, connection purpose. It will be used. So if switches are promiscuous mode, they are vulnerable to security attacks like spoofing IP address or capturing the Ethernet frames. And compared to it is higher in cost compared to hub or other connected device, less than the router. So router is a L3 device which is used for connecting multiple networks. Comparatively than the other networking devices, this is used for communicating between the networks. Earlier one it is used for same architecture, but here we can also get the help for adding multiple architecture in the switch in the router, so we can be able to communicate between different networks. So it like router is like switch is maintaining a switching table, router is maintaining a routing table, which is very much useful for identifying the systems for the network, for getting the details and passing on the information to the destination machine, and sending the information to the destination. There are three major differences between router and a repeater or a bridge. So what are the three reasons? So one is router has a physical and logical IP address for each interface. So I have Ethernet interface, serial interface, and voice over interface, multiple interface available. So I'll be having the interfaces for individual devices, not like your switch. So that gives advantage, right? It'll have a separate controller, and you'll get faster communication. So it works in the layer 3 and passes the network packets to other systems. So advantage: easily shared internet, security and adaptability. Routers limits the collision to the domain, so there will not be any collisions. Routers can function as LAN and WAN. It can be used for both LAN and WAN. So it is used for connecting to different architectures like token ring and Ethernet. So if required, we can use that also. Disadvantage: it is more expensive than other connected devices. Uh, the routing updates, the frequent updates will be sent from this router to other router, that is consuming more cost, and it is a complicated setup. Without knowledge, L3 knowledge, you will not be able to do anything in the router. Next is the gateway, the advanced form of connectivity device. It is a component that is part of two networks, which is used for different protocols. So earlier we said different architecture. Now this is for different protocol what we have. So normally gateway will be working in all the layers. So that it is communicating in all the layers and sending and receiving the data from all the systems, all the layers. So it is also forwarding the packet to different networks and trying to find out whether the system is available in that network or not, and then only it is communicating to the devices. So interconnecting devices. So how it is connected? Advantage: the direct linking between internal and external hosts are denied. So in network gateway, the user level authentication or protection is supported and can connect our links to variant networks. So it can connect to different networks, so that is not a problem, right? So the protocol conversion is done and it handles the traffic problems. So once the protocol download is completed, then it will immediately take up the communication process. Disadvantage: it is not an intellectual equipment. Router is manufactured by multiple vendors. Cisco router is a famous one. So um, Cisco gateway. I mean, we can also have different types of devices from different vendors. Whichever is best for our environment, we can utilize it. So we have reached the end of the topic. Um, we have covered multiple devices available and each differences. And currently we are using switches and routers for any kind of environmental connections. So we have reached the end of the topic. Thank you very much.